All right. Okay. So thanks for coming. I am going to present on serverless platforms, demystifying them, to show what's under the hood. So who am I? I am Aditya Relangi. I work at Capital One. I am here from Dallas. Uh, my I basically work on the data management team for auto finance. So my team handles all the data that comes in when you guys apply for loans. So as part of the team, we get to work on new stuff. Uh, Serverless is one of them. ML and some blockchains. But I'm here to talk about serverless. So what I'm going to cover in this talk is there's basically three components to this talk. One is the first part is how serverless came about, the history behind it. That's the opinionated part of the talk. But after that, we will look at what a serverless platform means, and we'll see how we can build one by ourselves. So my idea of demystifying this is so that you know what's under the hood, you are better able to handle it. And the best way to learn about it is by actually building one out. With that, let's get started with the first part, which is how serverless came about. Initially, we had the monoliths. When we started building software, we had monolith applications. Everything was tightly packaged together. All the functionality was one part of the system. And you had multiple teams working on a really large applications for months on end. You would have deployment cycles of 3 months, 6 months, and a year. And in making any changes anywhere is really tough. You had to coordinate with other teams, ensure that your changes don't break theirs. And by chance, if somebody else's error caused the system to crash, the entire system was down. So it wasn't really easy, very tight coupling of components. It was really hard to do deployments, maintenance, everything was hard. So even though we aimed for modularity, the modularity didn't percolate all the way up to the application. So from monoliths, we moved on to service-oriented architecture. With service-oriented architecture, the idea is, hey, we have modularity. Let's take it a step further. And let's have different services that tie in with, that talk to each other. But still, there was a lot of tight coupling between these components. Even though these were separate modules, it was one single deployment monolith. So it was a step in the right direction, but we didn't go all the way ahead. So, and then we moved on to microservices. With microservices, the idea was pretty simple. Have each atomic functionality be its own application. So instead of having one large database, each microservice would have its own single database. So even if one part of your application is down, you still have the other running. For example, let's say your payment system is down. Even if your payment system is down, your users would still be able to access the website and work with it. So everything was small. At the same time that microservices came about, the industry started embracing Agile, which meant small teams would all start building on a single small functionality, and they would own it. So deployment was easier. And instead of in service-oriented architecture, you had really tight protocols to communicate between the services. But with microservices, we had REST APIs that could communicate. So there was more flexibility with microservices. And yeah, so with that, everybody was happy. Everything's great. Microservices, amazing, right? Not to be. So what we ended up doing is we swapped one for the other. With the breaking of monoliths into microservices, we started encountering new complexities. And those complexities are like this. So this are called Death Star architecture diagrams. This isn't very bright, but the idea is these are diagrams that represent all the microservices these services were having and their interdependencies. So the nodes are the microservices and the vertices are the dependencies. Now that actually that image from Netflix is from around 2014, 2015. Twitter was around 2015, and now you can imagine how much that would have ballooned up. Like even at my team, we handle about 500 microservices that are quite interdependent on each other. It's really hard to maintain them. Now, what does this have to do with serverless, right? So one of the things that we realize with microservices is that not all the microservices, not all the applications need to be running all the time, right? So, uh, like Jeff Atwood says, like the best code is no code at all. Uh, if you take that and you apply it to infrastructure, the best infrastructure is no infrastructure at all. So let's say you have a microservice and you don't need it running all the time, right? Uh, an example of this would be like an image uh, resize, image manipulation service, right? So let's say you have an image, somebody uploads it to your server, and that that application has to, what that application does is it basically resizes your image, creates a thumbnail, creates it multiple images for different resolutions. Now this application is basically running on that server waiting for an image to be uploaded, and the only time it runs is when you have a new image. It creates that new sets of images, throws it output, saves it somewhere, and then it again waiting. Now this application doesn't have to be running all the time, right? It's just waiting for some event to happen and then kick it off. Now, if you take an application like that and you have all these number of microservices, you're maintaining all that infrastructure. What if you only run that application when you need it, right? You invoke that function or that application only when you need it. So I'm going to use the terms function interchangeably with program or application. It all is the same. It's all the same. So the idea is pretty simple, where you do not maintain a server for it. If there is a service that would run your application only when you need it, that is what serverless actually means. So serverless basically stands for there's no permanent infrastructure, and I think this is a really good definition of what it encapsulates. So applications that run in stateless compute containers. By stateless, the applications or the containers, the applications running on those containers do not maintain any state by themselves. Any state uh, is directly provided by us, by the particular event that calls it. So the request and response contain the state. The application doesn't maintain any state, like the image thing. We provide the image to the application, uh, and it does that. There's no maintaining of state anywhere. And they are event triggered, right? So when certain action happens, that is when the application runs. Uh, like the image example, again, the image lands on a particular location and it triggers an event and the application runs. And they run in ephemeral on ephemeral infrastructure. So by ephemeral, the application is alive only for the duration of execution, after which it's gone. Uh, and these are fully managed by a third party. Basically, the infrastructure is fully managed by a third party. You do not own any infrastructure. You do not handle that. So another example of serverless that you may or may not be aware is Alexa, how Alexa works. So Alexa, I think it's the same with OK Google. So when you invoke Alexa and you ask for something, uh, the services that actually, apart from the machine learning, the speech, understanding the speech part, once the speech is translated, it calls for a specific service. Let's say you ask for the capital of England, right? Now there's a service that handles only capitals. That's a serverless application. So that is invoked only when this event happens. When you ask for capital, that is when that application gets triggered and runs and processes it and returns an output and dies. So, so serverless applications are already in production everywhere. You may not even know that you're using it. And yeah, so with that, these are the pretty popular ones. AWS Lambda, everybody knows it functions as a service. Azure Functions, Lambda was the first one that came about in 2014. And you have IBM OpenWhisk. IBM OpenWhisk is a little more flexible with what you can do. You can provide it executables, Docker containers, stuff like that, and it works. Google Cloud Functions, it's a bit lacking compared to, I would say, Amazon or Azure, especially because it's quite a lot of the language support is in beta still. So they still have to catch up. Um yeah. So with that, uh, we'll go into the second part of the talk, which is trying to understand what is under a serverless platform by actually building one. So why would you build a serverless platform? One, this is a purely educational, uh, intellectual curiosity thing. I wouldn't suggest whatever I'm going to show you, the code, not to put in production. I don't put it in production, but just to understand it. So I would like to quote Richard Feynman on this and say, like, what I cannot create, I do not understand. So that's the reason why we are going to build a serverless platform, just so that we can understand it. Another thing is, if you want to build it, if you want to roll out your own solution, there are some advantages, which is primarily there is no vendor tie. With any of those earlier services that I showed you, once you get stuck on one of these vendors, you are tied into that ecosystem. You cannot pick and choose which one you get to use. So if you're going with Amazon's, Lambda, you cannot use a Google Cloud compute engines. That doesn't fit. That shouldn't actually. Like, I don't know why you would want to have multiple vendors have that. But again, there's this thing with vendor time. So let's get on to building the serverless platform. How would you actually build a serverless platform? In order to do that, we are going to imagine ourselves as a infrastructure provider. We are going to be the Amazon. We are going to be the Google Cloud platform, and we're going to approach it from that perspective. So we're a hot new startup in this infrastructure space. We're building a functions as a service uh, system. So what makes a serverless platform, right? So in order to be a serverless platform, you need to be able to invoke applications, right? Some events need to be triggered and you need to call those applications. We need to have that ability. We need to have really small boot time. These applications need to come up quickly in a snap, within milliseconds, and they need to be isolated. So because these applications are going to run on shared resources, they need to be isolated from each other. They cannot impact the other applications that are running on your system, and they need to scale fast. So that is one of the other reasons why serverless is popular, right? If you want to scale fast, you can invoke multiple applications immediately without having to worry about scaling that underlying infrastructure. It scales very quickly, and you need to capture the compute time so that you can bill your users, right? You need to charge your users, and we need to be stateful. When I say stateful, the underlying platform has to be stateful so that you know which functions are running on your system. And when you bring it, if it goes down, you bring it back again. It needs to maintain that state. So how do we achieve this? We are going to rely on two things in order to build a serverless platform. One is containers. So uh, containers. So when I say containers, I'm primarily going to talk about Docker, because containers as a technology came into prominence only when Docker came about. Even before Docker, there was LXC, but it wasn't that easy to use, very hard to wield. And a lot of people actually didn't know they had the option. So Docker came in, excellent job. Now everybody's using it. There's other options, Rocket, which you can use, but still Docker is popular. So we're going to use that. What containers or Docker provides us is these things, which is really small boot time. You can bring up your applications really fast, and it provides that isolation we need, and we can scale fast. We can bring up multiple containers pretty quickly. So, and for the other set of features, which is these, for maintaining the state, to capture the compute time and the ability to invoke functions, we're going to use a web server. And the way we are going to do that is we're going to write our code in Go. We're using a Go web server, Docker, and we're going to name our application called Granda. The us underlying serverless platform is going to be called Granda. So with that, let's go on to the demo. And let's see. So this will be our site. Nice and friendly because I started. Oops. What happened? Okay, cool. So we have this site. which people can basically sign up at. So it basically says, hey, any events we capture through our API gateway, if your application is Dockerized, we can run it on a platform, and you can direct that output anywhere you want. So all you need to do is Dockerize your application, get user image name, and we'll do it. Right? Some of the features. Your application is basically a Docker container now. You only pay for what you use. You don't have those servers running all the time, and there's a lot of flexibility. You can use any language, any environment. We don't really care, and it's very easy to deploy because again, it's all Dockerized. So if you want to just use this, we come in here, and so for the purposes of this demo, for this part, what I'm going to do is I have an application. I have a Docker image, and it's a Go program. It's a basically a Go program, and all that does is it basically writes a tweet from this handle. It's Grander demo. So I ran it yesterday, last night. But as you can see, when I invoke that, when I run the Docker container, it's going to write a tweet to this. So now I have Grander running on my machine locally. So I'm going to create a new function. Let's see, let's call it node tweet, right? Description, write to handle. And the image name is tweet go, because I already have the image locally. But if it's from a public repository, let's say I would basically say that as my Docker username slash.
What we're looking at now is this a framework that you're using to build your app, or is this an example app that it's entirely your app?
Yeah, it's an entirely yeah. So you would basically provide the username, the Docker username slash basically the repository, and we can pull it. But since I have it locally, I won't. And we're going to provide a timeout so that your application, in case it timeouts, we're not hogging all the bandwidth and stuff. So I'll just give it 15 seconds. And when I create this, I am basically provided with a URL. When I created my function or application, I am provided with this URL. And when I invoke this URL, my application will run, right? It has to be event triggered. That event is invoking this URL. I'm going to take this. Okay, it got called because I clicked on it, but that's great. Which means I should have a new tweet over here immediately. So yeah, 11 seconds ago, because we invoked that URL, right? It called this from a Go program, inside a Go program within a container. This is the UTC time frame, and there's a host name. Host name is basically the container it ran off, right? Now, if you notice, the host name is different from earlier, because of the ephemeral nature of the serverless platforms, right? We are running that container, and it's alive only for the duration of that execution, right? It's not constantly running. It comes up only when it's invoked, which is where you see different host names. Now, this is nice, and this is very simple. But if all you can do is in your let me come here. This is our what's this? Oh yeah. So if all you can do is basically invoke it and not do if all you can do is basically invoke it and not do anything much, like if you can't pass in data into the container for you to process it, it's not of much use, right? Like the image, you need to, like the image example I gave you, you need to tell your container where the image is. If you just invoke it, it doesn't do much. So we can basically do that. And so as an example, I'm going to use this post to this URL query and say, hey, node, yeah, hello from Amherst, right? And I'm going to call this, and we got a success message, which is great, which means we were able to again invoke it, and we were able to pass in some information in here, which is this, right? So whatever message we passed in, the container took it and then posted it as the tweet that we wanted. So we are able to basically communicate with the container, with the application inside it. So that's nice. So how did we achieve that? We did that by, so we're going to take a look at some code. The code is written in Go, pseudo Go. Kind of, even if you don't know Go, you should still be able to follow.
Would you be able to turn off maybe half the lights? I have a little glare.
Yeah.
Thank you.
Oh,
I think it's that red one. It's this fire alarm.
Thank you.
yeah. So this is going to be, so yeah, let's take a look at the code. So this is a code for the server, the web server. Now this struct that you're looking at, that's basically a representation of the form that we had. If you remember, we asked for the function name, we gave it a description, and then the image name, the Docker image, and a timeout. It's basically one-to-one mapping of that form. Now, so we're going to, here what we're doing is we're importing the Docker library to communicate with it, the Docker client library. And in my main function, all I'm doing is I am creating a new client, the Docker client. I'm initializing that. I have a router to handle the URLs. So I have the create func on invoking this create func. I have a create function handler. It's running on 8881. Now, what happens in create function, right? When you basically click the button, the create function is invoked. And in create function handler, what I'm doing is I'm just extracting all the data input, the input you gave. For brevity, I just included the image name, but we also get the description and the timeout and stuff like that. And we create this image object and we send it to the create function. Now, what create function does is very simple. It checks if the image exists, which is the image name, and then if it doesn't exist, it pulls it from the Docker hub, Docker repository. And yeah, it pulls it from the Docker repository if it doesn't exist locally. And then it generates a unique URL endpoint. It associates that with that, and it creates a new path to handle when that container is run. And we store that data to the database to maintain the state. So that's how we basically create a new function. That's what happened. When we saw that URL come up, this is all what happened in the background. It checked if the image was there locally, it associated a new URL to that, and provided us that URL. Now what happened when our function was invoked, right? We called the particular URL, we invoked that particular URL. That is when this happened. The container run handler function got invoked. And container run handler, all it's doing is it's checking who called it, and it's again calling the run container function. And whatever response it gets back, it's writing that back. And what's happening in run container, the bulk of what's happening in it is basically we start tracking the time, right? So that we can charge our users, so that we know how long that container is running. We start tracking the time. And then we create the container based on that image name. Because of the ephemeral nature, we're creating the new container every time. We don't actually have to do that, but for the sake of this demo, we create that new container. And yeah, we are creating that container based on the image name. And we are starting the container, which is we're running the container. And we are waiting for it for the duration of the timeout. We are only waiting for the container to run for the duration of the timeout. And if it doesn't finish execution by then, we are force killing it. If not, we wait for it and we say, all right, it's all fine. So we return the response of success or if it's done. Once it's done, we are basically removing that container. We're cleaning up after it. And we save the compute time to the database. Make sense? So how did we pass in the data into the container then, right? So what the way we're passing it is, if you're familiar with Docker has this uh, feature called entry points. So there's command and entry point. Entry point is where you say, this is where my executable is, this is where the application should start running. So that is what entry point does. What we're doing is we're basically leveraging that entry point, and with entry point you say, hey, this is my executable, this is my first parameter, second parameter, and those get passed into the executable. So those are the arguments. So the earlier run container did not have, what it did not have is, okay, so what the earlier run container did not have is this, which is basically us passing in the message into the container. So whatever we read the body, which is the body, the message, the tweet I put in, hello at Node Summit. We read that body and we pass in that body here, which we're passing into the container, and the container is handling whatever you want to do with it, right? Make sense? Okay, so that's great. But as a developer, if you're working with a serverless platform, you might come in and say, hey, you know what? I wrote all this code, but I don't want to learn Docker. I don't want to know how to build Docker images. I don't want to store them in some repositories, and I don't want to do any of that, right? That's a little more work to do than what you anticipated. So how would you handle that? We have a better version of this, which is Granda EE. Now, what Granda EE does is, let's see. Now there's more options to work with. You can either provide the image like earlier, same thing, or you can actually just put in the code you have. So the way we're going to do this is, what I'm going to do is I'm going to do a little live coding. And so you've seen this page, this web page. People can use it, but if people are interested, there is no way for them to sign up or reach out to us. So what I'm going to do is I'm going to add a contact us or form at the bottom of the page. And when they contact us, when they provide us their email information from the backend, I want us to send out an email to them. But I don't want to put in any infrastructure into this, right? I don't want to deploy some backend code when I do that. I want to use Granda in order to achieve that, sending that email out. So I already have the code for writing out that email. Oh boy. Sending out that email. So it's again Go code. All it does is this is my main program. I get the user input. I unmarshal it into this form. I get the full name and the email on the backend, and I'm using the Mailgun API to compose a new message. Right. So this is where it's coming from. This is the subject name, and this is the message we want to send in that email. Now I already have this code. So I don't want to bring up any server, and I'm going to edit so I'm going to create a new function, function using this. I can come in and say, okay, I have my code. So I'm going to call email. I'm going to give that name and description, send email. And I'm going to give it a 15-second timeout. I'm going to select the 1.7 runtime, and I'm going to paste my code here. With that, yeah. So when I create this, I'm presented with another URL. Now what I can do is take this, copy link address, and I'm going to go to my index page, the index.html. So this is the code for the index page, and I have this form over here. This is the contact us form, and when this form is submitted, when this form is submitted, I have this function, the Ajax call, to call this URL, right? So this URL is what I got from Granda. Now I didn't push any of my changes anywhere. All I did is create this, and I have a URL to invoke. And I'm sending it the full name that the user puts in and the email. So if I refresh my if I refresh my index page, I should see a new form here, right? I just added it in. I'm going to give it my something, and I'm going to give it a an email address, so that we can check. I'm going to give it a mail. Okay, I am going to give it this at mailinator.com. For those of you that don't know, Mailinator, it's a public inbox. That's what it is. So I gave it some random email, and I can check this public inbox. So I'm going to click on this. So unfortunately, because my JavaScript skills are really bad, I didn't add a feedback when it was submitted. So right now, the only way I can check it is I can check the email, which is at this public inbox if I got that email. And we did, right? So what happened is I didn't have to push my code, deploy my code to any infrastructure. I didn't have to bring up a server. I didn't have to restart my server. All I did is I changed some front-end code. I submitted some back-end code to some completely other site, right? So how did we achieve it, right? And that is, let's see, how did we achieve that? Is basically we have a better create function now. When we are creating this, what we're doing is we are taking all the input. So let's see, this is similar to the earlier form, which is we are getting the user input. Now we are also taking in the runtime that the user wants to run on, and we are taking in the code, and we are creating this tar file. We're basically first creating the Docker file. The Docker file is based off of this inputs. What is the runtime they want to use? What is the language they want to use? And the code. Yeah, we create the Docker file, and then we create a tar file using the Docker file and the code you give, and we're creating a Docker image based on that. So tar path. Then I have Docker build context is based on the tar path, and I am building that name. So I have the image build options. So one of the inputs I can take in is how much memory I want to give this container. So I can specify that over here. I can specify how much memory, how much CPU I can provide to this container. So that flexibility is there when you're creating these images. And then I build this image, and from there on, once I have the image, everything is like earlier, right? I already have the image. I just call the create function, which takes in that image, creates a new URL, returns that. Everything else is the same. So that's what happened when we did all that. And so how do the sample Docker files look? This is how they look. So when you specify the runtime, we are going to use the base image, the base Golang 1.7, and then we created this directory. We also extract the packages that you need based on the code you provided. So we imported the Mailgun API. So we basically extract that from the code, and then we install this, run this. So something so have another application which is similar, which is basically if you have Python, this is how your Python Docker file might look. Now, yeah, that's basically it. The idea is pretty simple, right? You as a platform are basically taking in some code, you are packaging it into a container, you're running it when you need it. Now, there's definitely optimizations that you can do. For example, I am using these base images, right? Now, these images are really, really large, like about 400, 500 MB. Now, I can optimize over here quite a bit and reduce that image size. Now, if I use multi-phase builds for Docker, that becomes even smaller. Now, another thing that I'm doing is every time the application is invoked, I am creating a new container. Instead of doing that, I can have the same container running up. I can have it hot loaded and call that. So a lot of optimizations that can be done. But basically that is it. This is what is under the hood of a serverless platform. Now, yeah, basically what does that mean, right? Does serverless mean there's no code? There is, except you don't get, there's no servers, there is, except you don't get to see them. They're underneath, you don't get to see them. So with that, any questions?
That was a great demo. As a non-technical person working with product teams, that was super helpful. I'm not particularly interested in it, but I am curious to ask. You know, one of the challenges brought up with the monolith and the SOA and microservices was that it's just sort of shifting the pain. What is management of, you know, do we suddenly have